Hello, and welcome. Ben here again. So today, by special request, we're going to be working on sine, cos, and tan triangles. Now, for this maths qualification, level 2 further maths AQA, what you've got to know is sine 30, 45, 60, 90, cos 30, 45, 60, 90, tan 30, 45, 60, 90. Now, one option is to remember all of these off by heart, but some people can find that difficult, including me. I'm not very good at remembering, numbers and things. So, if you find this particularly difficult, sine, cos, and tan triangles can really help you with this. So now, if you remember from your high level GCSE, this is SOHCAHTOA. So to work out sine of an angle, you've got to do opposite divided by hypotenuse. Cos of an angle, you've got to do adjacent divided by hypotenuse. And tan of an angle, you've got to do opposite divided by adjacent. And this is one way that I learned recently, actually. If you write it like this in sort of little triangles, it helps you to remember the sine is opposite over hypotenuse. It just helps you to remember the divided by. So now, if we move on to the triangles, if you look at the things we've got to learn, we've got to remember 45 and 90 for each of the sine, cos, and tan. So to help you do that, we've got this triangle. Now, as you can see, this is a right angle triangle. It has to be to work on sine, cos, and tan. So if you look at basically the dimensions of this are one, the two sides are both 1, and then obviously that means the hypotenuse would be 1 squared plus 1 squared, which equals 2, and then square root 2 with the size of the hypotenuse here. So that's simple Pythagoras again. So that's our basic triangle here. Now if we go by the angles, this will obviously be 90 because it's a right angle triangle. This will be 45, and this will be 45. So all the angles have to add up to 180. So now, one thing we've got to do, we've got to remember, is sine 45. So if we go back to SOHCAHTOA, remember that sine is opposite over hypotenuse. So sine 45 equals opposite over hypotenuse. So if we go with this is the angle that we want, then opposite is obviously the 1, and hypotenuse is square root 2. So sine 45 is 1 over square root 2. Now this can work for any of them. So tan 45, if we remember tan is opposite over adjacent, then this will help us with tan 45. So the opposite over adjacent, the opposite of this angle is 1, adjacent is 1, so tan 45 equals 1. Now that's how it works for the 45s. So then if I do this for the 90s, which you can also do with this right angle triangle, you can do it both triangles, but we'll do it on this one for the moment. So if you try and work out cos 90, for example, so cos 90. Now if you remember, cos is adjacent over hypotenuse. So if we're working out this, the adjacent will be this one, and the hypotenuse will be this one. So cos 90 equals 1 over square root 2. So that's how we'd work out. So if you remember this triangle with the opposite and the adjacents being 1 each and the hypotenuse being square root 2, then you can work out sine 45, sine 90, cos 45, cos 90, tan 45, tan 90. Now if we move on to the second triangle, which is dimensions of 1 by 2, this will help us work out sine 30, sine 60, and 30 and 60 for the other two as well. So I said it's 1 by 2 dimensions. This means that this angle will be 60. Obviously this will be a right angle because a right angle triangle has to be for this to work. Then this angle will be 30. So we do the same again. So to work out cos 60, let's say. So if we go with this angle here, cos is adjacent over hypotenuse. So cos 60 equals the adjacent, which is 1, over hypotenuse, which if we work out using Pythagoras, will come to 1 squared plus 2 squared, which is 1 plus 4, which is 5. So this one will be square root 5. Oh, sorry, square root 5 in there. So that means that cos 60 will be 1 over square root 5. So again, you can do this with the 30s as well. So sine 30 equals, so sine using SOHCAHTOA is opposite over hypotenuse. So the opposite for this angle here will be 1 over square root 5. So just remember these two triangles. Let's just go over them again. We've got a simple right angled triangle with dimensions 1 and 1 on the opposite and adjacent, and then that will come square root 2 on the hypotenuse. And just remember the other two angles are 45, and the other triangle, which is obviously right angled triangle again, with angles 60 and 30 with dimensions 1 by 2, with hypotenuse at square root 5. So if you remember all these, you can work out any of these sine, cos, and tans. Well, thank you very much for listening, and good luck with your sine, cos, and tan triangles.